ruined my life.
Okay, so senior YY. For 39, what are we doing? We're finding f of g of h. Okay, so that means we have to take the h function and put it in here for the g function. Okay, so the g function says square whatever you plug in. So since I'm plugging in that whole thing, that means it's going to be x cubed plus 2 squared. Not done yet, but that's taking this piece right here and plugging it into there. Okay. Then the f function says take whatever you plug in, subtract 3 from it, and then take the square root.
So then you put all of that into
It's just for the x. So I'm going to take all of this, x cubed. Oh, I don't like it when it does that. X cubed. I said I don't like it when it does that. Are you not listening to me?
It is.
X cubed. Scott is really sensitive all of a sudden. Since I got the new projector, which doesn't make any sense to me. Like that.
Yeah. See now, and this is where.
No, then you're done.
Not the fixed answer does not.
Well,
No, you're
what the
done.
book did is that they actually spoiled the.
They foiled that out.
Yeah.
The book says x
Yeah.
to the degree of x to the degree of 6 plus 4.
What is 21 squared? 441?
Well, it's just 2.
Huh?
It's just 2.
Oh, that's a
It's
parentheses.
just 4.
That's a parentheses, huh? Okay. So, sorry, plus 4
No, not 4.
So
minus 3.
So that's my fault.
So so the middle shouldn't be 42.
So it shouldn't be 42, right? Sorry, plus 4. Where did I get a 21? 21. Okay, plus 1. Sorry, just had to do that. Okay, so that's the final answer. If you can get to here, I'm okay with that.
Oh, I messed up.
Okay. The rest is just
I
sort of.
imagine that's the same for when we're talking about questions like 30 and 33 where they're asking to combine things. And I have to do things like cosine
Yeah, just
inside of cosine and
Yeah, it's all good. Okay, you said what, Darius? 48?
48. I just want to see if I did it right.
Okay.
I think I did on my sheet.
Express the function in the form of f of g of h. So now this is just like the question that Y had asked, but backwards.
Yeah, so it would be
So f, g, and h. So
f would be root 8 of x.
yeah, the f function is the very farthest outside one.
Then g would be 2 plus x. And h would be absolute value of x. Okay, I did that right there.
You take this, plug it into there, you get 2 absolute value of x. Take 2 absolute value of x and plug it into there, you get 8th root of 2 plus absolute
I
value.
find it easier to go the other way.
You do the inside and then
I
work
did
with.
each first.
Yeah, that's what I do too, but it's fine. No. Okay. And then Gabby, Bobabby. Oh, by the way, the secret bonus word for today is football.
I thought it was going to be tough.
If anyone who is absent today comes in on Monday and says the word football to me, then they get extra credit. That's evidence that they actually watched.
Do you want us to do it like sneakily, like we're not making
No, you are here, so you're not eligible. You're not eligible.
Oh, okay.
Sorry. All right, 51. This is a great question. I'm glad you asked about it. It's very important that you understand how to do what we've been doing with composition of functions on a graph, okay? A says, what is f of g of 2? So that means here's the g function, right? G of 2, to find that, you go over to 2 on the x-axis and then up to the graph. And the y value right there is 5. So g of 2 is 5, right? Now we're going to take 5 and plug it into the f function. So you go to 3, 4, 5 on the x-axis and then go up to the graph, and that's 1, 2, 3, 4. Okay? So f of g of 2 is f of 5, which is 4. All right? So, same thing for all the rest of these. G of f of 0.
So 0.
g of f of 0 is first figure out what f of 0 is, and so that's 0. And then figure out what g of 0 is, and that's
3.
3.
Yay.
F of g of 0 is the way you read that. So for C, you're doing it backwards. So you're going to figure out what g of 0 is first. And g of 0 is 3. And then f of 3 is 0.
Yay.
D, g of f of 6.
So F of 6.
F of 6 is that 6? Yeah. 1,
6.
2, 3, 4, 5, 6. So g of f of 6 is g of 6, and g of 6 is
Undefined.
undefined. No dogs allowed.
That would be.
Okay, then g of negative 2.
So that'd be
It
negative
really
two.
doesn't make sense.
Negative 1,
Why is it negative 1?
because if I go to negative 2 on the x-axis, then go up to the graph, I get negative 1. And
I
then,
know, it's still positive 1, because
oh yeah, you are correct. Who said negative 1?
you did.
You did.
I didn't say anything.
Do we need to go to the tape? We have this on tape. We have it on
I
video.
didn't do it.
Okay, so then we need to figure out what g of 1 is, and g of 1 is 1, 2, 3, 4. And finally, f of 4.
Final 4. Final F 11.
Final countdown, f of 4, 1, 2, 3, 4, and then 1, 2. So then take that and plug it back into the same,
Negative 2.
and you get negative 2. I'm right that time.
Right.
Okay, any other questions?
Maybe like a few more minutes.
Last section in the chapter. This is a short one. And I don't know how this is going to go, because this is designed to sort of teach you a little bit about using graphing calculators, but technology is changing and evolving. So this might be a little bit outdated, all right? But we'll just give it a try just to see how this goes. And either you can do this on the graphing calculator or you can do it on Desmos. It's up to you. So maybe this will be good, because this will give us a chance to see what Desmos can do and what it can't, or how to do those things in a new system, okay? So the first one says, draw the graph of the function f of x equals x squared plus 3 in the following viewing rectangles. So x squared plus 3 looks like this. I feel like I've already had a conversation with Jordan, I don't know, maybe who else, about how to change the scale on this thing. Tyler? Okay.
A little
We figured out, yeah, if you go up to the tools here, and then you can just, whoops, highlight that and change it to, what did they want the window to be?
2 negative 2 on that?
Negative 2 to 2, negative 2 to 2, okay.
Is this in the book somewhere? So I can look at it?
Yep. So the nice thing, one of the many things that I like about this one is the old TI calculators, you had to distinguish between a negative and a minus. And on this one, it's all the same thing. So you can just go -2 and 2, and then you're done. Okay? Oh, I guess I wasn't supposed to change the scale there. So that's the graph in the window. Negative 2 to 2 in the x's, negative 2 to 2 in the y's. Good looking graph, huh? Yeah. All right.
So this whole assignment, basically, there's going to be no paperwork.
Yeah, looks like it. All right, so now let's go negative 4 to 4.
Window.
That's no problem.
And is your scale never changing?
Oh, yeah, You can change that here, I think, where it says step. I haven't ever messed with that yet.
But RE is what I'm saying.
Should I?
Well, I don't know, it's a part of the question.
No,
Alright then.
but let's mess around with it. So right here I have it -4 to 4. What do you want to go by? Twos?
I'm just saying 0.7, okay.
Okay, so if you change that, then it just goes by twos instead of by whatever it was.
Oh my goodness.
Okay, okay, I don't feel like doing the rest of that example. Is that okay?
Oh, there's a zoom square too. Whoa.
Where's that?
Go into your workshop, please.
My workshop?
I mean, your little tools.
Tools,
And if it's not squared up, since it's not squared, it'll square it up to one of them.
Nice.
So like mine, I did the very last one, so now everything's up to 1,000, so I'm like really tiny.
Huh.
Yeah.
Okay, got it. So if you put a step in there, yeah, okay. What does the arrows do?
I was really tired when I was
I don't know.
applying 2 lane.
Oh,
And then I posted my
probably puts it
application as my personal essay
at the end.
as I'm just a girl.
Oh, it puts the arrows on the X and Y axis.
Oh, okay. Big deal. All right.
There is 2 lanes.
So let's say we were going to graph and look at the function square root of 8 minus 2x squared.
Well, go back to this
Free, but I'm not.
for a second. I just found
You
this.
do not try to.
I got more like.
Go to the little tool thing. See the grid?
That is,
Click on the circle one.
Like that's
It gives us a little pie
Yeah,
chart.
probably, then, yeah.
Right, that's for polar equations, yeah.
That's sweet.
Yeah.
I mean, gave me.
We should get turned.
No, but it's.
Okay, so let's do this next one. Square root of 8 minus 2x squared. So we get rid of that. Totally awesome.
Nice.
Okay.
I did do square root of.
That was easy. It seems like this stuff was more complicated
Back then.
back then, yeah. These are pretty straightforward. Okay, graph the function y equals x cubed minus 150x. Why? I don't know.
That's sweet. They give you like little examples.
Yeah, there's little activities that we can work through.
Free account.
X cubed, and what was it? Minus 150x.
So it's gonna go down 150.
What it does is it puts a line in the middle that has a slope of negative 150. So it takes the regular x cubed graph like this, and then there's now, now this piece in the middle has a slope of negative 150. Okay, so that's why it's hard to see that here, because it is so steep. So can you see it now, kind of?
Whoa. Okay.
So, and then this line, this segment in the middle has a
I
slope
see.
of
So you're
negative.
talking about like it's doing the thing.
It's,
But
yes.
in the middle where it's flat, where it would normally be flat when you put negative whatever,
Right,
it, or
Because they're not
it
there, right.
just makes it.
So if
tilt.
I graph negative 150x, and you can see it goes right on top of that line.
I didn't get that.
Okay, that's okay. That wasn't really anything to get.
I'd never seen that before.
Okay, how about sine of 50x? Let's go crazy with the trig here. Do you know where the trig functions are in this?
You go to functions,
Uh-huh.
and then it's right there.
So then it's trig is the default one, so I'm gonna go sine of, what was it, 50x?
Yeah.
Okay. All right, and so this is clearly a bad window because it looks like a horizontal line. And so I'm going to zoom in a little bit. And then this is where we had some problems before. What I want to do right now is I want to find a way to maybe leave the x's the same, and I want to zoom in on the y's, okay? And so that's where we went to this thing right here. So I'm going to maybe leave the x's the same, probably going to end up changing those. What does it look like? What values does it bounce in between in the y-axis?
Probably
Point.
pi over 50.
I like what you're doing there because you're coming up with sort of a relationship with it at the period of the function,
Yeah.
but the period is defined in the x direction.
Oh.
So what's the amplitude is what we'd be looking for the up-down stuff. Yeah, 1. So I'm going to go -1 right here and 1 here.
I mean a barcode.
What just happened?
All those, all the up and down signing.
What just happened?
Yeah, that's what I did.
Yeah, I made a barcode.
What's that?
I made a barcode.
See? You zoom out, I went too close together, like the periods are so close together that it's like.
Okay, so then we need to change the x's a little bit too, maybe, okay? So I'm gonna piggyback on what Darius said. He went pi over 50 because of the sign of 50x, and he's close, but not quite.
Well, that's the middle, so it would be 2
No.
pi over 50.
Right, 2 pi over 50. Yeah,
Do you wanna
because it's
be
2 pi
in
over the, so if I go pi, you always want to be in radians when you're graphing trig things. So I'm going to make my x minimum be negative, donde está el pi, oh, right here, pi over 25, and then I'm going to make, oh, I don't want that right
Do you
there.
think they have another word for that?
I mean, looks like a nice fuzzy cloud.
And then make this be pi, there we go.
There, we can see it now.
Divided by 25, okay.
Wow, that's really small.
Yeah, so that's a very, right, so that's a very, very small period. And so the moral of that story is make sure that you're thinking about the graph itself, the function itself, and how that's going to affect the graph. Don't just blindly draw the, put the graph on here and then draw a straight line on your paper because that's what came up. You have to think about what's the amplitude and what's the period, and then use those to help you define your window, okay?
And a barcode.
Why?
Because you're doing it old school, you're doing it on the thingy, okay? All right, so how about the sine of x plus 0.01 cosine of 100x?
This is
So let's see if we can find this. Yeah, this could get a little gray.
Okay.
Sine of x plus minus plus 0.01. Nope, I know, but I didn't do 0.01. 0.01 cosine of, is it 100x?
Yeah.
Okay, this is going to be a hard one
Was
to
it
find.
0.01 or was it just 0.1? I think it was 0.01.
I don't know.
You can always double check, I guess.
0.01.
Okay.
Okay, so it's there, right? You
Are
can't
the
see
windows
it.
too small?
Which way?
The x axis.
Okay, so let's make the x's different. What do you want to go from?
20 to 20, I don't know.
Oh, something just happened fun right there. 20 to what?
I was going to say 20 to
I'm
20.
going to go 2, well, I'm going to go 2 to 2, negative 2 to 2. What are all those dots on there? What's happening?
Those are points.
Do you have 2 lines here?
Do you know where all these dots come from? On the these dots automatically pop up on this thing to show little maximum and minimums.
So it's going up
And so what this is, because I have my base function is sine of x, and so that's this thing right here. But then when I add on the 0.01 cosine of 100x, it makes it a little squiggly line instead of a smooth curve. So that's why you're getting all these tiny little maximums and minimums. So let's change the, I don't know that that's going to matter any. But okay, so you see a little bit better if we zoom in there, what's going on with that? That it is the normal sine graph, but then it's just sort of modified a little bit with the cosine on top of it. Okay, we are all in here. Draw the graph of the function y equals 1 over 1 minus x. This is one of my, I guess I have a lot of favorites about this calculator, but one of them is that when you type the divide button, it gives you a fraction like this. So on the calculator that Wyatt is using, you would normally have had to put the bottom in parentheses. So you have to go 1 divided by parentheses 1 minus x, but now since it gives it to us in fraction form already, we don't have to do that. Okay? So there is that graph, and there is the other piece of that graph. You all know that this is an inverse function, right? Where is the vertical asymptote?
1.
At 1, because you can't plug 1 into here, because you can't divide by 0. So I get vertical asymptote right there. Can we graph x equals on this? If I graph x equals 1, will it show up, do you think? 'Cause that's another weakness of the TI. Yeah, there we go. Okay, so you can see that that is a,
Oh, it even gives you a little slider thing.
What is
that's a
that?
vertical
You can
asymptote.
slide it to change where the X is.
Sorry, bad. So there's our vertical asymptote. And then normally, I'm sure you remember that the inverse function is in the first and the third quadrant. It looks like this.
I actually did remember that.
I was being sarcastic. I didn't really expect you to remember that. But this one, I know it's been shifted, but it's sort of in the second and the fourth. Why did that happen?
Because it's negative X.
Because it's a negative x, good. So you can either think of that as flipping it over the x-axis or the y-axis. It's symmetric. So they're both el mismo. Okay, cube root of x. Anybody explore how to do cube roots on this yet?
No, actually.
I haven't either. Any bright ideas? And then we can do it with fractional exponents.
Put a 3 in front of the square root,
You think?
maybe? I don't think that would.
No, that's 3 times. Are there some other functions that we can choose from?
There's already a cube root of this calculator.
Oh, nth root right there. Okay. So if I do that under miscellaneous, then it'll give me an opportunity to enter in a
How do you do that?
value right there. That was under functions, and then miscellaneous, and then nth root right here. Whoops. And then we wanted to do the cube root of qua.
Is that
Just plain old x?
Yeah, isn't it?
I don't know. That's why I'm asking you. If I knew, I wouldn't have to ask. Okay, cube root of x. So, yeah, you should recognize that as what function flipped sideways?
The cubed.
Right, x cubed function just turned different direction.
Do you know how you cube root them?
Yes, that one you can go to the math menu, and I think there's a cube root in there somewhere. Okay. Okay. Graph the function. So this is what you and I were discussing, Darius, and so why you said you didn't get that before. We can do it now. Y equals x cubed minus cx. I feel like there's a way to do this with the slider bar also on this. So if I go x cubed minus, what the heck?
You put x squared 3.
I did. I have a bad, I keep hitting the squared instead of the, okay, x cubed minus, should I try just typing in cx?
That's what I did.
Did ya? Add slider. Wonderful.
And I did not get it.
Okay, so if I take this and move it around,
Make it a straight line.
when you say that it's 0, then it looks like the regular cube. It's so cool. If I go this way, for some reason I'm feeling like I lied to you because this is now C is a positive and it's, because it's minus CX. Okay, so this roughly has a slope of negative 2.6 in the middle. Okay, and if I keep sliding that there, then that makes that a steeper and steeper.
You're just making the amplitude bigger.
Sort of. It's not a trig function, so technically it doesn't have an amplitude because if I zoom out a little bit, it goes forever this way and forever that way. But yeah, you're right. These two humps are getting taller or smaller depending on
So
the
if we were to graph
value.
y equals mx plus b, would it pop up with a, would it give you a slider too?
How would you put a second variable on there?
Okay, so let's try mx plus b. Not in the book, but let's just have a little adventure. Mx plus b. Man.
It's actually really cool.
Actually, really cool, yeah. So I can change the b value, and you can see that that's the y-intercept. And then I can change the slope, and you can see. Okay. Find the solution of, okay, so I haven't done this yet. Cosine of x equals x to correct to 2 decimal places. So, what happens when there's no, okay. What do you think?
What do you mean?
How do I do it?
Cosine of x equals x?
Yeah, do I just graph cosine of x equals x?
I would assume so. Oh, what?
No.
That gives you the hazard.
I mean, why don't you communicate this?
Okay, yeah, so that's no good.
Well, this is an actual college application essay that the kids sent to like Stanford.
Oh, it wants you to tell when those two are the same.
Yeah. So how do you think I find this intersection point?
Well, you can do that.
Yeah, but I don't know. Am I just trying to get lucky and just hope that it's in the right spot?
You zoom in a lot, and then you press it.
Oh, there it popped up. Okay, so if you zoom in close enough so that it can find that point, then that'll give you the intersection point. That is totally awesome.
That's actually.
Yeah, you have to go through a lot of different steps to be able to do that on the TI, and this is obviously much faster. Okay. All right, fun stuff. Boy, you guys are just so lucky to be alive and in this next generation. No, I don't know how to do that. You want to walk me through that a little bit?
Let's see if we can, yeah.
Okay.